Hello everyone, welcome back to another video. In this video, we're going to be touching on various types of beam loading and how we go about calculating the reactions, as well as some other nuances that surrounds these load distribution on various beams or slab. Now the first type of loaded beam that we want to look at, or I want to look at, is known as a simple, let me write that, simple central loaded beam. Now, what does this look like? Let me go ahead and produce a quick free body diagram here. So we have our beam here, right? And underneath this beam, we're going to have at either end a support. All right, now these support will be called RL for the left side and RR for the right side. Now, there is going to be a force or a load acting on this one here, and we're going to put it exactly in the center, and this is what is going to make it simple. Let's give this a value of 400 unit. Let me write that correctly, 400 units. All right, and the distance between the force, as you can see here, let me pop in some dimensions, is going to be smack in the center. So say let's make this 3 meters and 3 meters. All right, now this is the first type of loaded beam that we're going to be touching on. Simple centrally located beam. Now for this one, the top load on the beam is 400 unit. So it therefore means that it is going to be required, or it will require 200 units at each reaction point at RL and at RR minimum, all right, in order for this to be in equilibrium. So in order for this to be stable, we need to have 200 on this side here and 200 on this side here, because the 400 is centrally located. All right, so let's go ahead and see if we can do some quick calculation to determine that value. All right, now the process remains the same. So when we're writing this up, we'll say moments. So moment is equal to load multiplied by the distance. All right, so this is how we determine it. All right, so let's go ahead and do the reaction or the moment at RL. So let's write moments. All right, and this is going to be at RL. That's RL right there. Now, how do we determine this? We're simply going to be multiplying the load by the distance that it is away from RL. So we're going to have equal right here. Then we're going to have 400, all right, multiplied by how far is it away from RL? 3. All right, and this is going to give us a value of 1200. All right, now once we have that in place, the next thing that we're going to do, we need to determine the moment at where R, and this is going to be equal to, similar to previous video, R, all right, R multiplied by the total distance between the two reaction points. In this case, it is 6, which is 3 plus 3, all right, and that should be equal to the total moments in this case, which is going to be 1200. All right, now we need to make RR the subject. So in order to make RR the subject, we need to move over that 6, leaving RR on that side there, and this is going to be now equal to 1200, all right, divided by 6, and this will give us a value of, so RR is going to be equal to now 200 units. All right, so that is basically how we went about getting these values here to determine the reaction. Now this here is a pretty simple um, scenario. All right, and over the next few videos you'll see the other scenarios coming out. All right, so this is it right here. This is how we will pretty much complete this one here. Now if you found this video helpful, don't forget to go ahead and leave a like, share, and subscribe. If you need assistance with classes or lessons, feel free to reach out. I'll see you in the next one.